Hey y'all, CB here, and I'm the No BS welder with NBS Welding. Good to have you. We're rolling in the super service truck, headed eastbound, headed towards town, going to the other side of town to an area we call Hickory Flat. Feller out there that contacted me a while back has got a wood-burning stove with a crack in it. He thought it was cast. The stove is not that old, and he wanted to know if I could give him a price on repairing it. Part of this has to do with the fact that the stove is not very old, and the manufacturer of the stove is paying the bill. I told him there was absolutely no way I could give him a price on it, especially after I talked to the manufacturer, because the person that I talked to, the representative from the company, didn't even convince me that they knew what the stove was made of. Now, if you're going to do a weld repair on a cracked wood-burning stove, this could be mild steel, it could be a hardened steel, it could be cast steel, it could be cast iron. I haven't seen it. I'm just going loaded for bear, and whatever it is, I'm going to do my best to fix it. I explained the situation that there was no way I was going to be able to quote him a price on the job. One aspect of this is, if I find it to be mild steel, hardened steel, or cast steel, then I would most likely weld it with a 7018 welding rod using a stick welding process. If it's cast iron, I would still arc weld it with a stick welding process, and I would most likely preheat and use a nickel rod. The big difference with regards to using a 7018 low hydrogen welding rod or nickel rod is your 7018 is going to cost you around $5 a pound. Your nickel rod is $50. Yeah, I said $50 a pound. I bought 3 pounds to bring with me on this job, and I spent $150 on welding rods. Now, there would be some people who may mention and say, why didn't you go out and find out if it's cast iron before you spent $150 on welding rods? Well, that's something to consider. I charge $75 an hour for my time. By the time I go there, find out what it is, and come back, that's $150 worth of my time. I mean, I would have spent 2 hours, and really it would have probably taken more than 2 hours out of my day. Because just about anything you do, even if it takes less than a half a day, it consumes half a day. That's why in a lot of cases 4 hours is my minimum fee. So that was something to consider. Are you going to buy fresh cast rod, nickel welding rod, if it's cast iron to use, and take with you? In my case, yes, I'm going to. That's what I decided to do. I may not need those rods, and if I don't need them, hopefully I can store them in a way that they'll be okay for use when I need them. And I've had decent luck doing that with those rods, so that's not something that concerns me. Another pretty cool little tidbit about this is the feller that owns this stove was my 8th grade social studies teacher. So when I talked to him, when he approached me and talked to me about this job, this was somebody that I used to spend time with every day that I haven't talked to for 38 years, which was neat. So anyways, I've brought 2 Arc Captain machines with me that are in the box in the super service truck. One is the Arc Captain MiG 145 Pro. It's a good little machine for this sort of stick welding. And one thing that I have learned that I did not know on previous reviews of the 145 Pro is it does run 7018 a whole lot better than I thought it did, but you have to have the right 7018. So let me explain that little tidbit situation. The Hobart and Lincoln. Lincoln makes the Excalibur. I also like a Hobart 7018 that I run. I can't remember the number or what designation it is. But the 7018s that I generally use that are dedicated DC rods, those don't stick weld very good with the Arc Captain MiG 145 Pro. And the reason they don't is because that small of a machine has a very low open circuit voltage. Now, your bigger Arc Captain machines, you know, once you hit the MiG 200 and up, they all run all 7018s fantastic. None of them will run 5P plus or 6010 rods really well, but the one that does run them the best, in my opinion, is the MiG 205 MP. That's the multi-process that's got the plasma cutter in it. That one to me seems to run 6010 better than any of them, but it doesn't run it as good as a high dollar inverter or true DC stick welder would. So the trick that I've found that actually makes the Arc Captain MiG 145 Pro run 7018 really well is you've got to use the 7018s that are for AC. While we're headed down into Mr. Evans' basement to see what we can do about helping him out with this wood stove, I want to mention something that's very dear to Mr. Evans. He wanted me to share about Skyhope to pals. This is an organization that offers free flights to medical care. If you or someone you love needs medical care and it's more than 2 hours away and it's something where you need to get on an airplane and get there, Skyhope offers free flights for those. They offer that service, and Mr. Evans' wife flew with Skyhope a lot during her cancer treatments. Now, we did eventually lose her, but the treatments that she was able to get going all over the country extended her life by several years, and it's something very dear to Mr. Evans that he wanted that to be shared. And you can find out about Skyhope by going to the website palskyhope.org, palskyhope.org, info at palsservices.org, or 1-888-818-1231. Now, we're going to get a little better look at this welding. Here's the main crack that the customer found. And so let's just look at whatever we can see here overall on the stove and any issues we might be able to point out or concerns. Obviously, we got a crack right here. Another thing I noticed is looking at this pretty close up above here on this area right here where the steel had been rolled, I could see mill scale flaking away underneath of the paint. That is a telltale sign that this is a hot rolled flat bar. So we do have a mild steel here. It's probably a 1/4x2 hot rolled flat bar. And what I could also tell is that this spot right here is where two flat bars meet and are supposed to be welded together. Something we could speculate that might possibly have happened is where they welded these two together, they didn't have a bevel or a root opening or a way to get good penetration, so they didn't fuse their steel together with a solid weld. And another thing we see is we can see that they ground the weld off on the outside there. So if you didn't get good penetration and then you ground what weld was on the outside away, you don't have nothing left. And one of the things that happens is even if the crack formed right here, just as a result of a poorly welded joint, that crack, I always say it's like a zipper. It'll just keep going. it expands and contracts and continues because you have an opening there and you got a piece of steel. When this thing's at rest, it could be 30, 40 degrees in this guy's basement, maybe, less than 50 degrees anyways. And when he's got it cranking, it could be 800 degrees. So you got a piece of steel here that goes, there's drastic changes in its temperature. So that's something that's going to cause steel to break itself. We move on and look at these brackets right here where these are brackets that hold the door on. And what I see here is severe weld undercut. Undercut is a weld defect where the electric arc and the heat of the weld machine was used to dig into the steel, but the filler metal wasn't used to fill that in. And that leaves a void. And when you have a severe undercut like you have all the way across the top of this weld right here, that's a place where cracks are gonna want to start because you've cut into them, you've scored it. You've basically scored the metal. If we think about what other defects we've got here, you can see we got a start. This is a start of a weld where it's nice and thick. Over here is a stop and there's almost nothing. And not only do we have that, but the ends of these brackets on either end are not welded at all. So they left an opening where expansion and contraction could cause the two pieces of steel to continue to want to come apart. And that is undesirable. Now, if we look at the bottom of this same bracket, we can clearly see this is where the ends weren't welded at all. That's undesirable. We've got severe undercut and something that looks like cracking at the lower edge of that weld bead. And then the next thing I see is that the end of this bracket is right here. Well, look at the way the welder deposited his steel. How much good does it do to help hold this bracket if you got all this steel on the plate and you got that tiny little bit of metal up on the bracket? That is something that should be split even with a good fillet weld that would provide an even amount of steel from the bracket to the plate that it's being fastened to. So we see some defects there. Now, if we look at the top, this is the top of the bottom door bracket. What we see here is more undercut running across here. We also see this little void right here. We also see that right here is the end of our bracket. And we got a bunch of weld here and only this much weld here. And we also see that the ends of it are not welded. All of those, as far as I'm concerned, could be considered weld defects and things that could have been done much better. For one thing, the ends should probably be welded. If somebody's standing there with the welding equipment in their hand, really, how much longer is it going to take to weld all the way around this bracket? Another thing that you can do in a situation where you're welding a little bracket like this, these starts that are nice and thick, you should have that at both ends. So in a lot of cases, if you're welding across something like this, you might start here and weld this way and then do a restart here and come back with an overlap in the middle. That way you've got a nice thick start at both ends. Or maybe you weld the end of this, leaving a heavy deposit at the end and then start on that deposit over here. See, if you started on a weld deposit over here, you're not even on the bracket yet. So you can really get a puddle going before you even get to the bracket. That would be another way. Whatever you do, you don't want to have this effect where there's a tiny bit of metal on one side and a whole bunch of metal on the other. The thing that makes this really undesirable and inefficient is there's plenty of weld here. It's just been put in the wrong place. So all the money was spent. it just, the job didn't get done. So that is undesirable. If we move on now, this is opposite the side where we looked at the first crack, but we got to look here because I see this ain't good. See that? Let's get a little closer. Let's see what we can see as we get zoomed in here. This isn't now this hasn't cracked yet, but as far as I'm concerned, it does need attention because right there, that's not fused together. That's a splice in those two flat bars that is not fused together, and the expansion and contraction that's going to take place right here will cause this to crack, especially the way this is welded with. You got a start right here that looks like a big skip, and then a big deposit here, and then they finally got it together and have a bead of reasonable width. But in all of this area right here where it's critical at the end of this, this is poorly done. So these are all defects that we want to point out and show each other so that we don't do it no more. We're all trying to get better. Not trying to, pick on anybody other than we want to improve. So if something can be done to eliminate these kind of voids and undercuts and poor weld management, poor deposit amount, we need to fix these issues. Got everything out pretty much here that we're going to use for this repair. I've got the Arc Captain MiG 145 Pro. Got the power cord drug in. I'm going to be running the Arc Captain off of the Miller Trailblazer 302. These are the AC 7018s. This is a Lincoln brand 7018 AC RSP in 3/32 inch diameter. This is what I'm going to be doing the welding with on this stove. So we get out the stinger, we get out the ground clamp, get the cover pulled off the MiG 145 Pro. There's the adapter that I use where I'm actually plugged into the 220 on the Trailblazer, and then I pull 110 volt off the 220. Don't trip any breakers or anything that way. That works real good, so I can run that machine hard. And the first thing that I'll do at the end of the crack that we've got, take my cordless drill, and I'm gonna stop drill a hole right at the end of that crack. And you see me holding my hand down there because I want to show you. We saw mill scale on that material, but here's another telltale sign that we're dealing with a mild steel is the way it drilled out curlicues. No sort of a cast would do that. You wouldn't get the curlicues coming out when you drilled it like that. So the next step, you see me with my angle grinder and my cutting wheel, and I'm going to cut me a pretty generous root opening on these cracks. I want to get that weld back in there. I want to get that 7018 in there where it can fuse that steel together. So using the cutting wheel, I was able to get in position. You can't always do that. On the brackets, actually, that I would like to do more grinding on those brackets on the door to remove the weld that's there, but it's not feasible really. You would have to it'd be hard to do and not hit other parts of the stove. So what I'm going to do is I'm going to repair it by welding over top of it. That's just the quickest thing to do at this point. So we've got our grinding done what we can do, the power brushing done what we can do, and I got a couple of wrenches out of my wrench pack, and I took the door off. Now, I did notice if the repair that we were doing was on the door, it would be a cast iron repair. That was a cast iron door. There's no doubt about the way that the door is made. It is cast iron. Either cast iron or cast steel. On the way the door is made, the only way that you'd be able to tell if it was cast iron or cast steel for sure, to me, would be to try to cut it with an oxyacetylene torch. Because an oxyacetylene torch won't cut cast iron, but it will cut cast steel. So, here we're just shooting some video, pretty much of the beginning of what we got going on, and to some extent, you know, this is what it looks like when I'm getting ready to start welding on it. It is pretty much what I'm showing you. Starting out on this, taking advantage of the stick welder, something you can do with that is bend that rod, because I want to reach in behind here, and I'm going to start out welding that hole shut that I drilled. That's the first thing I'm going to do, is weld that hole shut and start welding by coming back towards me. So that's what I'm doing right here, and then I would probably want to make a restart further out at the end right there and weld back, and then when I meet the weld that I'd made to begin with, there'll be a little area where I can overlap. That gives me a nice heavy start weld on both ends, so we don't have that crater where a crack can start. And another thing about stick welding or flux core welding, you see a lot of novice welders, they'll weld a little bit, and then they get out their grinder or their power brush or their chip and hammer, and they chip, or they grind, or they run the power brush, and they just did a, you know, one little bit of welding, and then they're power brushing, and then they're welding, and then they're power brushing. When you're doing these operations where you've got to do flux removal and you've got several things to weld on, go ahead and weld on several things. Go ahead and get some weld on there. You see me jumping around a few different places here on this steel where I'm getting some weld in some different spots before I'm going to bother getting out a power brush or a chip and hammer and cleaning anything off. It's just more efficient is really the main thing. It's going to take you a lot longer to get anything done if you make a little 2-inch weld and then power brush, and then make a little 1/2-inch weld and power brush. I've seen a lot of novice welders do that, and I think it's a matter of them wanting to look at what they've welded, which to some extent, you know, if you're setting your heat or whatever, that makes sense, but don't overdo that. Get some work done before you do your weld cleaning. All right, forgive me here, guys. Give me a minute. Let me do a little advertising for the channel. These are the NBS Welding t-shirts that we got for sale. You can get an NBS Welding t-shirt for $25 plus shipping. If you email Tina at nbswelding@aol.com, then she'll get with you on what your shipping cost is going to be and get you a t-shirt. Now, in the description of my videos, there's links to our Amazon storefront. If you do anything with Amazon, use our link to get there, whether you're buying items on our storefront or just buying something else. It'll help the channel if you use my link. We also are an Art Captain affiliate, and the links to the Art Captain site is also in the description of my videos. So if you use our Art Captain link, then Art Captain will know you got there because of me. And if you buy anything from Art Captain, use the promo code NBS Welding 5%. You'll get 5% off, and the channel will get a little credit for that. I want to thank y'all for your support. Now, leave me a comment, like my videos, and share them to anybody that you think would enjoy them. Thanks. Here we just got some high-speed video of finishing up the welding. And pretty much what went on here was I did several passes there on the inside of that door. That's an area where you could really put as much weld as you wanted. It's not going to hurt anything. But that offered reinforcement, and being able to weld on the back side like I did when I bent that welding rod and added a lot of reinforcement on the back, that helped. I don't think we're really concerned about the aesthetics of it, the way the stove looks in a basement like this. So I would not grind the weld off anywhere that it didn't need to be ground off. leave it there for strength. And this is another little part of the video that I got that I'm including. And the reason I feel like this is interesting is because until I saw that I did this on video, I had no memory or thought that I grabbed that bucket and leaned on it like that. That was something that I pretty much did on autopilot, and was kind of surprised when I saw that I did that on video and didn't really even remember doing it or thinking about doing it. But what you can see right here is that I had to get myself into a position that would have been really tough to weld in, and it became really easy because I was able to set my elbow on that bucket. Hey y'all, CB here. I'm the No BS welder at NBS Welding. I'm coming to you today to tell you about the Arc Captain and NBS Welding welder giveaway. We're giving away an Arc Captain MiG 145 Pro, just like I'm welding on the bottom of this skid steer with right now. I'm going to tell you how to enter to win. You got to comment the word Arc Captain on this video. Share this video on your social media account. Subscribe to both the NBS Welding and the Arc Captain YouTube channels. And you'll be entered to win an Arc Captain MiG 145 Pro, just like I'm welding with in this video. Great little machine. Runs off 120 volt. I'm running 030 flux core wire on the bottom of this skid steer. And I got a Bluetooth connection with the Arc Captain app in my phone, so I can adjust my heat while I'm laid down underneath the machine. Don't have to get up and get out of position to turn my machine up and down. Make the adjustment on the machine while I'm staying in position where I'm welding, and I get right back to work.